Good morning, good day and good evening. That's my final video report for Reinforcement Learning Course 2022 at Innopolis University. Practically touches the second assignment of the course. In a world of random size, with a random number of cargos, it's necessary to arrange them so that they all fall in a terminal zone of random size without intersections in the minimum number of steps. At the same time, it's guaranteed that they can all fit there and find a solution in a finite number of steps. Here, the red letters in the grid world is a reward zone. In the same time, the green letters mentioned like once it's part of cargo. First of all, it was necessary to create a world that cargos could understand their or relative location in a world. Based on the conditions of the task, I decided to present the world in the form of simple grid, as we did in task earlier, that each cargo has the coordinates of each part of it, and the same applies to reward zone. Each cargo was presented as a tuple of two coordinates, the upper left corner and the lower right corner, highlighted in yellow. The same was done for reward zone, highlighted in purple. Thus, it was easy to control the movement of cargo on a field and check the stop status, if they terminated or not. Since the number of actions is limited only for each specific cargo, and the quantity of cargo itself is not limited, I decided to save the state for a specific cargo. In addition to coordinates, I will also denote the reward received in this state, the number of cargo cells in the reward zone, and the number of intersections. For a small number of actions, it was enough to create a small neural network, which in my case would predict the probabilities for each action. The goal was to find the relationship between the coordinates of the cargo and the coordinates of the reward zone. It would be obvious that it should be distance. Due to some problems, which I will talk about later, I chose a sigmoid activation function. For a normal choice between exploration and exploitation also, I used softmax with temperature. The result presented here is was a map by size 9 by 5. The smaller the green dot on the ordinate axis on the graph, the better. I've used 10,000 epochs and 100 maximum steps in each epoch. In such a situation, you can find a way and correctly arrange the coefficients of the model so that it can more or less produce a consistently good result. As we can see, it coped well with the task for one cargo on a map of this size. In the process of solving assignment, I faced with several obstacles. Some of them I found a way to overcome, but some of them are not. But what I can say, it works well for small map, for example, as I presented earlier. It works well for one cargo on those maps. Sometimes it works also well with similar initial conditions. For example, if we make the map, there's a left side contains the reward zone and the right side contains the cargo, no matter their coordinates, but the matter their logical relative relationship, then it could be solved. And also, I found a way to choose the trade-off between exploration and exploitation. Then we don't need to take the weird action when we have already found a way, and we don't need to use some another action. There are several problems that I couldn't overcome or overcome partially. For example, it doesn't converge if cargo more than one on a grid. Another problem is cyclic walks. It means that cargo goes to left, right, or up, down, and so on and so on. It could be a bigger oops. It partially solved with delta rewards, and the next problem is nonce in probabilities. It means I thought that I used ReLU function that it could affect it, and that's why I put sigmoid function instead. Also, another problem is non-bijective maps of state. It means that for done positions of cargo on a grid world, the representation of the state that I passed to the model could be the same as for different situation. But in case of several cargos, for one cargo it would be different. And another problem is wrong reward that I described a bit earlier. Instead of passing the true reward, we don't pass, we use it to say the loss to model. We use delta of rewards. In a summary, I could say that something works well, but something not. Yeah, solution is far from ideal one. But I gained some knowledge from a real particularly from machine learning, because I forced to use machine learning model approaches to approximate function. And action value function and learning algorithm, for example, not to scary words anymore that I firstly heard about them. And I really tried to read some chapters of the Richard's book, but yeah, it's huge, and we actually passed the course too quickly, so it was hard. Uh, that's all for my report. Thank you for watching.